My name is Millicent Warner, and I will be presenting my Lab 1 video on charged tapes. First, let me go over the schedule for the video. I will start by introducing some key ideas, formulas, and data from the experiment. I will then find both the quantitative and qualitative results, and after show my GlowScript code model to visualize the results. Lastly, I will answer the thought questions provided in the instructions. The first of the fundamental principles before I get into calculations is Coulomb's law, which is an equation to calculate the electric force due to two charges that are a certain distance away with their own charge. The formula is a constant times the product of the two charges divided by the distance squared and multiplied by the direction vector. Next, an electric field indicates an area surrounding a charged particle that other charged particles would feel a force within. It is important to note that an electric field is dependent only on the source of the field, not the particle experiencing the field. The formula is a constant times the charge of the source divided by the distance squared and multiplied by the direction vector. In other words, the electrical force is equal to the electric field times the second observation charge. Lastly, the most intuitive of the principles is the gravitational force, which is the attractive force between two objects. For this lab, we will use this formula to calculate the gravitational force between the Earth and the upper piece of tape. The formula is the mass of the tape multiplied by the acceleration due to gravity in the negative y direction. Let me make three assumptions about this lab. Firstly, I am ignoring the air resistance on the moving tape. Second, I am assuming that each U-tape has the same net charge, and that charge is evenly distributed along the tape's length. Third, I will treat each tape as if all its charge were located at a single point at the center of the tape. Here are some initial observations I made in placing the charged tape next to various objects. When I put the U-tape next to my hand, it was attracted. When I put the tape next to another U-tape, however, they were repulsed from one another. When the U-tape was placed next to a table, there was a slight attraction. Most notably, when I put the tape next to the negatively charged plastic pen, the tape was repulsed. For your information, I charged this pen by rubbing it through my hair. This last statement of interaction affirms that the U-tapes are negatively charged. Now I will introduce the procedure to estimate the amount of charge on a U-tape. I will start by making two U-tapes by swiftly pulling the upper tape off of the base tape on the table. I will then check that the U-tapes have negative charges by seeing if repulsed by a pen. After this assertion, I will hold one U-tape below the other until the top one floats. At this point, I will record the distance between the U-tapes. Here is a visual of the physical model used in this experiment. The two U-tapes repel each other as they both had the same negative charge. In this way, the tapes are expected to repel each other with equal magnitudes. Note that U-tape B is considered to be floating when there is no movement in the y direction, or no net y force. In other words, the electric force and the gravitational force are equal in magnitude and opposite in direction. Let me state some of the important values regarding this experiment. The length of both U-tapes ended up being around 0.215 meters, and the mass of each was 0.000215 kilograms. The width of the tapes were 0.0225 meters, and the distance between the two tapes once flotation was achieved was around 0.023 meters. I multiplied the mass of a piece of tape by the acceleration due to gravity to get the tape's individual weights. I then multiplied the length by the width of a tape to get the surface area. The number of atoms was calculated by dividing the surface area by the area of a singular atom. Because the upper tape is not moving in the y direction, we can postulate that the electric force is the same in magnitude but opposite in direction to the gravitational force. Next, I rearrange Coulomb's law to solve for an individual charge of one piece of tape. I can then divide the charge of the tape just calculated by the charge of an individual electron to get the number of excess electrons. Lastly, I may find the ratio of excess electrons to atoms by dividing the number of excess electrons by the number of atoms on the tape. The code to visualize the data runs as follows. I entered in all of the initial values needed to begin the experiment, including K, length, mass per meter, distance, atom length, tape width, and electric charge. I then entered all of the equations that I previously explained into my code. In order to create an image, I wrote two spheres to represent the tapes as point charges. I further drew in the gravitational force and the corresponding electric forces. Here is the simplified version of the experiment I conducted, and the sentences are reported in the outputs below. Any differences between my values and the MATLAB values are largely due to my truncation of numbers during calculations. What if electrons had positive charge and protons had negative charge? And how would this impact our observations? Well, even if signs of the electrons and protons changed, the magnitudes of all of the forces would remain the same. In addition, the tapes would still have the same sign and charge relative to each other, so there would still be repulsion and flotation as seen in the lab. Also note that the charged tapes would still be attracted to neutral objects because polarization would continue to occur. Why is it important to handle the charged tapes as little as possible? By charged tapes, we mean the U-tapes possess excess electrons. The excess charge will want to move towards a more neutral or positive object, so when a neutral object, touches the tape loses electrons. If the tape is less charged, there won't be as dramatic of electric forces as the force is proportional to each U-tape's charge. Thank you for watching, and here is a link to my GlowScript code.